Hey everyone, Mr. Kim Singh here, and today I want to talk about solving linear equations with fractions. Now, fractions are sometimes a cause for fear in some students because I guess the tricky thing with fractions is because they have their own kind of set of rules when we look at their arithmetic and their operations. The thing I want you to take away is that fractions are just another way to express division. So when you think about division, you're grouping things up, right? That's what fractions basically are. I suppose the difference is that we can use numbers or expressions here, right? So there can be a point of confusion. And today I want to help clarify them. A few things just to note, right? So fractions can be expressed in a variety of different ways. So for example, if I have x on 2, so something divided by 2, that's the same as half x here. Let's use a numerical example here, right? So if I, for example, have 4 divided by 2 here, right? That's the first situation. I know that's equal to 2, right? Let's have a look at this one here now. Half x. Remember, if I have a number in front of a letter, it means I'm multiplying, right? So if I want to take half times 4, what's that equal to? It's also equal to 2. So hopefully you can see that these are two of the same thing. Now, something that I want to note is the order in which you rearrange the equation. It doesn't affect the final result, but it can make solving certain questions easier when we are doing things in a certain way, in a certain order. So my recommendation is to undo. What I mean by undo is to do the opposite operation of the last operation which was done to the expression. That's a bit of a mouthful, but I think it makes more sense when we look at some examples and see how that actually helps us solve the equation, okay? So let's have a look at these. So these are our fractions here. And just remember, what does a fraction mean? Go back up. A fraction just means division between numbers or expressions. So division, that's division. And remember, what's the opposite of that? The opposite of that is just going to be multiplication. So that's the key part to solving these. We want to think about the opposite operations here. So I'm going to multiply both sides by 3 because that's the opposite operation. And my goal is to get x equal to something x by itself. So when you multiply both sides by 3, what happens is that the fraction and the multiplication by 3 divide through on the left-hand side. And on the right-hand side, well, you're just doing 10 times 3. And I know that's just 30. All right. So that's how we can solve an algebraic fraction. Now, something you might have noticed is, hey, I could have done that in my head, right? Because if you look at this, this is saying, what's something divided by 3? That gives me 10. And you can think about it and you'd get 30 as your answer. And that's perfectly fine. But something you need to note is that when we get to more tricky examples, it won't be as easy to do mentally. So that's why it's really important to have these strategies here, okay? So let's have a look at this one. So this is an example of what I mean. It's not as easy to think about, okay, what is this saying? 3 times something divided by 5, that gives me 6. It's just a lot of mental gymnastics you have to do to try and get to that point. So what I'm going to say, an easy way of doing that is, all right, let's go ahead and use our operations here. So I'm going to multiply both sides by 5 here, because that's the opposite of this division over here, right? So I'll multiply both sides by 5. And so on the left-hand side, this fraction is going to go away. I'll get left with 3x is equal to now 6 times 5. That's just 30. And so then I'm going to think about, all right, what does this 3 mean in front of the x? Well, that means 3 multiplied by x. The opposite of that would be dividing by 3. And so that's going to give me x is equal to 30 divided by 3, which is just 10. All right. And again, we can check our answer by putting it back into the original equation. So 3 times 10 divided by 5, that's 30 divided by 5, and it does give me 6. So this is how we can always check by putting it back into the original equation. Okay? All right, awesome. All right, a couple more. So, this one's an easier one for you. Do you want to try this one for me? Pause the video and have a go using the same methods there. Now, if you did this one in mentally in your head, that's fine too. But I'd love you to practice along with me doing it through the working out method. So here I've got something divided by 4, y divided by 4. And so I'm going to use the opposite operations of multiplying by 4 here. And so that's going to give me y is equal to 3 times 4, which is 12. Did you get that? Hopefully you did. Last one in this set, we've got this situation here. Again, I'm thinking about opposite operations. It doesn't matter which side the variable is on. I still want to remove this fraction by multiplying by 5 here. So I'm going to get 6 times 5, which is 30, is equal to 2x. And so let's think about opposite of 2 multiplied by x. Well, that's dividing by 2. And so 15 is equal to x. Now traditionally we like to leave the x on the variable on the left hand side. So I'm going to say x is equal to 15.